Okay, well, welcome everyone to our session today on protecting and recovering databases from ransomware attacks. My name is Tim Chien, the Senior Director of Product Management at Oracle, specializing in backup recovery technologies. We have a very interesting and timely topic today as recent events uh, in Europe have arisen. We have seen the heightened awareness and visibility of a ransomware and cyber attacks in our world and affecting our businesses, affecting social well-being. So it is a very important and timely topic. So I want to take you through the ransomware attacks, why are they so important and serious these days, and then talk about the Oracle database and how protecting the database from these attacks is a paramount consideration as well. So let's go and get started. So ransomware, as we all know, makes headlines on a daily basis. In my opinion, it is the greatest threat to business survival in modern times. And we're not in the traditional world where typical HA or disaster recovery scenarios might affect IT systems and applications. We're talking about a much more devious and much more sophisticated attacks that result in widespread outages. The stats are out there. I'm sure you could find these yourself on the public internet, where we see thousands of attacks happening daily. US organizations alone losing more than $7 billion in 2019 due to ransomware attacks. The average total cost of remediating such attacks is 1.85 million. And the worst case of all these issues is that there is downtime inflicted on the business because the systems are down. And the source that we have called Codeware, which does a lot of reporting on such attacks and analysis, has shown that an average of 19 days of downtime is incurred for each attack. So it is certainly extremely serious and very important matter these days. As I also mentioned, in recent events in Europe have only heightened that issue. Now, for the database side, which we're here for today, these can be extremely impacting. Even a few minutes or even a few seconds of an attack that can malign or corrupt hundreds or thousands of transactions. This can represent hundreds of lost orders, many, many millions of dollars worth of financial transactions. So the impact to the databases can be devastating to the overall business. As we all know that databases typically contain the most critical and sensitive information for a company's operations. First, a bit of background on how ransomware penetrates and what we view as C-level concerns in this ransomware lifecycle, if you will. The attack starts very innocuously as a email, fake software upgrade alerts, any kind of personnel infiltration that's done. So it enters through very innocuous and possibly not very well secured means. All right. So once the attack occurs, the concern at this point is what processes and steps are in place at this juncture, and are they being followed? So we're talking about securing credentials. We're also talking about securing access to external links and other types of actions that could come in. Now, once a ransomware can penetrate through that first level, typically the ransomware goes and tries to steal and to retrieve additional access privilege credentials across the environment, local, domain, and network credentials, with the goal of being able to access the data, right? Once it gets into a system, and finds data, it can manipulate and publish that data for extortion purposes. This is the whole point of the ransomware attack, is to be able to take that data and be able to hold it for ransom, right, until a payment is done or other means are arranged. So once data is compromised, the question that comes to mind to the C-levels is, what are the backup and patch strategies, and are they being successfully executed? Are there holes in any of our system protection methods and keeping our systems patched and latest with all the latest security vulnerabilities addressed and so forth? And do we have a plan for that? Even more sophisticated in some ransomware attacks is that they can then move into the backups themselves. So not only production data now, but into the backup infrastructure itself. And that can occur through connected NFS file share systems. Could happen through any kind of access point in which backups are made. But this now is in a much more serious point, because now your last resort is now potentially compromised. In order for ransomware to succeed, it has to be able to infiltrate all these levels and be able to compromise both the production and backup data. If all these levels are compromised, then you have a worst case scenario where you have no guarantee of data recovery on your own. And that's really the kind of the biggest part of this whole news headlines, is that ransomware attacks are happening and ransomware payments are being made. And so this means that many companies' backup strategies, and more importantly, their recovery strategies, have not been tested, are not really complete, are not able to be executed in a timely manner. So they must resort to paying the ransom, almost an act of desperation, to use all available options to get the production data back. So with that as a backdrop, let's take a look at the Oracle defense in depth and protection strategies for ransomware. We're going to look at the same life cycle, and we're going to look at various Oracle solutions that can target these attack levels. So the foundation of this defense in depth strategy is a foundation of solid and resilient backups. And so Oracle, and we'll talk about it more later on, introduced the Recovery Appliance for database protection, and to be able to have extremely low recovery point objectives, and to be protected at a transaction level with full validation of all backups. You can deploy Recovery Appliance in your production data centers, and for ransomware protection, you can also deploy it in a cyber vault, which is an air-gapped or physically network disconnected location. Moving up this life cycle, you also have mechanisms to defend if your data actually gets attacked, if that data can be used for any kind of extortion purposes. And this is where transparent data encryption, or TDE, is highly recommended for Oracle databases, to keep that data secured, encrypted, so that even if it was taken, unless the keys for that data were also stolen, that data is useless and cannot be used for to be published openly, or to be used for any other purpose. We also recommend using our engineered systems, which, as I mentioned, includes Recovery Appliance, and also for running databases, the Exadata database platform. The Exadata engineered system is built with security in mind, both internally in the system and for accessing data within the system. There are various mechanisms that we've hardened the components within the system, compute and storage, to be able to provide holistic protection and very controlled access for the data inside this Exadata database system. As you move up the life cycle where the attack initially started, you also look at where the privileged credentials were accessed by the ransomware attack. And so there are solutions such as Oracle Audit Vault and Database Firewall that can detect patterns of access and patterns that even SQL access that might portend to be potential malicious acts or some other compromise that's going on. And then finally, with credentials management, obviously hardening access to your systems, your servers, and your databases is paramount, right, as the first entry point. And with that, DBSAT, as well as user accounts, privileges, and rules of verification guidelines should be adhered to. Now, more information on these solutions and practices can be found in Oracle Database Security, documentation, and papers. Now, for this session, we're again going to focus on the backup side. And so the goal here is to not pay the ransom. Be able to have a complete, resilient, and recoverable backup solution that can be done without any data loss. And this is where zero-day data loss recovery appliance will be highlighted. So this appliance is an Oracle database engineered for ransomware protection. And there's three key technology pillars, as you see here, that this appliance provides. Number one, recovery assurance through real-time transaction protection and Oracle recovery validation, as well as very high-speed, fast database restore capabilities using dedicated network bandwidth. Resilient architecture, be able to have a separation of duty user model where roles for databases, the appliance, and for any related appliances are all separated in our user framework, and no one user can access other systems that are not privileged, been given privileges to do so. Secondly, immutable backups. Immutable backups prevent the backups themselves on a system to be compromised or to be purged or deleted by internal or external means. And of course, the hardened compute and storage servers foundation, which is built on engineered systems design methodology. And as I mentioned, stems from Exadata, hardware, compute, and storage history. We also will talk about Cyber Vault deployment, which means deploying a recovery appliance in an air-gapped location so that you have a physically network separated copy of the backups that is that can be retrieved at any time if your production systems are compromised. These recovery appliances in the vault are independently managed, both in their access and in their policies, to determine retention, other types of attributes of the backups on the system. And there's full reporting available too on the recovery appliance, which is obviously crucial for audit and compliance purposes. So let's take a look at the overall architecture here when we're talking about ransomware protection. I mentioned these three key technology pillars, but let's see how they come into this architecture. Your databases from any supported Oracle version, which is 12C to 21C as of now, on any supported Oracle OS platform, will be protected by a recovery appliance, which is designed for enterprise-wide backup and recovery needs. Each database is sending two pieces of data. One is a stream of redo, which is the change log of all transactions that's happening on that database. This is sent directly to the recovery appliance. And so recovery appliance has a record of every transaction that's executed on every database. The second piece of data that's sent is an incremental forever backup. And this backup allows recovery appliance to generate a virtual full backup that's whenever needed for restore purposes. On the system, we can then lock the backups for immutability so they can't be altered, deleted, or modified within their compliance retention time. And as I mentioned, you get very fast data recovery through the dedicated network bandwidth, as well as through our very fast virtual full restore capabilities. As we build out this architecture from production into now a cyber vault, this is enabled through real-time replication. So you have backups that are replicated from the production appliance to the vault, and that network, as I mentioned, is typically not open. When it is open through a firewall or some other switch in that configuration, it's used only to synchronize the incrementals and the archive logs that were backed up, and then the network is closed. You may also choose to archive to cloud, which is a great location for offsite encrypted backups and can also be made immutable on cloud storage. On-premise, you can also archive to our ZFS storage for same purposes. If public cloud is not an option for you, but you still require longer-term retention for compliance archive purposes, ZFS can support that. And as I mentioned, TD encryption is crucial for the data in general. TD prevents the data from being used for extortion or for other purposes to be made open and public. Unless the keys are also compromised, that data in the database cannot be used for any gain or purposes in that regards. The backups themselves are also validated end to end. And what we mean here is that at every place where the backup is made for the production database to the appliance, it's stored on the appliance, archived to cloud, or replicated to the Cyber Vault appliance, it is validated for consistency, meaning that the backup is complete and that all backups for a particular database recovery is present. So this will detect any kind of alignment or any kind of changes that happen to any of the backup data in any part of this lifecycle. So just to drill down into a couple of these technology pillars and a comparison, you can see that with typical third-party Bitcopy backup appliance, you typically take backups once a day. You might take your archive log backups several times through the day. But the bottom line is that you have data loss exposure for all transactions since the last backup, whenever that was. So a typical strategy is a full backup taken on a weekly basis and a daily incremental with archive logs that are also backed up on some regularity. Note that there is some potential for data loss, we call unprotected window, relative to the last time that an archive log was backed up. With Recovery Appliance, that is no longer in place. With real-time transaction protection through redo transport, we are transmitting, or the databases are transmitting, all transactional changes in real time from database memory buffers directly to the Recovery Appliance for immediate transaction protection. There is minimal overhead on the databases for this protection, as it's directly streamed from in-memory from the database side. And this zero data loss capability is especially important for databases, which, as you know, consistency of databases with other related databases and applications is a key design point. And so being able to have this transaction level protection and insurance is extremely important for overall business recovery as a last resort. Okay, we talked also about incremental forever, which is the other piece of data that is sent to Recovery Appliance. We use RMAN incremental backups to create virtual full backups. And what does this look like? On the first day, you do take a level 0 or full backup of the database. On every day thereafter, you take a incremental backup only. So this is just the change data file blocks relative to the previous day's full. So every day, a new virtual full backup, as you see here in day 2, is created. This virtual full is a metadata representation of a physical full backup that's recorded in the Recovery Appliance. When any database clients connect to the recovery appliance through RMAN and do a list report or a query of the backups available, they will see new level 0 backups automatically appear. And again, this is just by doing an incremental backup. And so forth and so on, that every day's worth of change blocks are taken relative to the last virtual full, and a new virtual full is created. So you can see that this results in extreme efficiency in backup storage. We're not taking any full backups anymore, just the deltas for using the incrementals. And we're also compressing these backups on the storage itself. So we typically see 10x less backup performance impact by eliminating the fulls on the production databases, and 10x less backup network consumption, because it is an incremental forever only strategy. Restores are also optimized by the recovery appliance. Because we create these virtual fulls, as I mentioned, restoring it from the database using RMN again. RMN is used for all operations, and it's the standard database backup recovery tool that a DBA knows about today. That virtual full is automatically assembled into a physical full backup. You eliminate the production server overhead of traditional restore and merge of these incremental backups that have to happen in a typical recovery scenario. So you get a new physical full backup that is caught up to that latest incremental point in time, and you could just apply the needed archive log backups from the recovery appliance at that point. Now, all of this is also inheriting the scalability and performance via the Exadata-based hardware platform. Database recovery validation, as I mentioned, is done at all touch points within our environment. From the time that databases are backed up, and if there's any kind of compromise or attack done, the RMAN tool would automatically detect that during the backup itself. It does a physical block checking of everything that happens on, everything happens during that backup. And if there is a bad block found, the backup job automatically ends, and you can take action to take an investigation or a closer look at what has happened in that case. Now, if a compromise or an attack happens in transit, this would be caught by the appliance itself. The appliance, as it receives the RMAN incremental backups and the redo, will validate everything as it's received. So any kind of compromise that happens in transit would be automatically detected and rejected by the appliance, and also stop that traffic. As we store the backups on the disk, and if there is any kind of compromise during the time it's on disk, this system also revalidates that data on disk. So it also does a pass on a regular basis to make sure everything that was written is still consistent from the time it was initially written. As backups are sent to cloud, and as they're replicated to another appliance, as for example in the vault, these are also checked on the way out. As it's received on the vault appliance, it's also checked on the way in again, just like on the primary appliance. So you can see that there are multiple locations where the data is checked, much more so than a standard backup storage solution, which would not have this insight into Oracle recoverability of the data file blocks themselves. The recovery appliance features a separation of duty user model so that each role in our environment, such as the backup operator DBA, the production appliance administrator, and the vault administrator, these three roles are completely separate from each other. They are defined with their own privileges, and they cannot cross roles in this case. The backup administrator, for example, can only back up and restore their privileged databases they have access to, but they cannot delete or alter any backups on the system. For the appliance administrator, number 2 here, they only have access to monitor and to manage those backups. They have no privilege to restore those databases or to look at data in those backups themselves. And then number 3, for the vault administrator, this person cannot look at backups, cannot take backups or restore to the primary appliance. They only have management and monitoring privileges on that vault recovery appliance area. So these are all separated and logically differentiated in our environment. On top of this, we have the ability to create immutable backups. Immutable backups are backups that are denoted as non-modifiable or non-deletable by any user. So for an example, we can look at a typical backup strategy, which you might have a business recovery window goal of 90 days retention. But you have another regulatory compliance rule that says those backups within that window for the first 60 days, they must be made immutable. What this means is that the backups will not be purged by the system. If there's any kind of other activities going on that system from other databases backups, no space will be freed within that 60 days. We'll ensure that 60 days are kept, and if there is more space needed for the 60 days because of activity growth, the backups will not make it in. Okay, it's that strict of a policy that backups will be rejected, and you have to increase free space or reclaim space from other databases by reducing their retention policies, for example. Remember, the system is servicing many databases, so the space is shared, their backups by all these database clients. Right? Same thing for the vault backups, where you have a immutable window, say, of 7 days. Within that 7 days, no backups can be deleted or modified by any backup operator, by any admin, even if the policy was changed from 7 days to, say, 3 days. Those backups that were existing at the time immutable window was set to 7 days would still remain in effect until that 7 days has expired. And similarly for OCI or cloud backups, that immutable window can be set for something longer. This is kind of where it's very cost effective for long-term retention, compliance, and so forth. Typically are years kind of level, and the immutable policies can also be set for OCI cloud backups as well. With a little bit more on the OCI part, these backups in OCI are integrated with Recovery Appliance. You get this configured with the appliance. It's an Oracle Cloud Infrastructure object storage location. It's a very cost-effective storage tier for this purpose. It can also help eliminate or reduce the need for physical tape or other types of traditional vaulting services. All data is compressed and encrypted as it goes out to OCI storage. So you have the best efficiencies as you send it over to our cloud, and it's always encrypted when it goes from Recovery Appliance. These backups in cloud use standard RMAN format, so they can be fully restorable directly from the OCI storage. For new cloud databases, for example, into DBCS or XCS services, or you can use them to restore to any on-premise location as is. So that's another benefit of these backups, is that they're portable and can be used for restore to any location. These backups, as I mentioned, are encrypted by default, and they leverage the Oracle Key Vault for key management. So Recovery Appliance integrates with Oracle Key Vault, which generates the key used for encryption, and it also retrieves the key that's needed during a restore operation from cloud. Just to recall that the Recovery Appliance, as I mentioned, knows about the life cycle of the backups. On-premise in its own appliance, it's replicated, or it's been archived to cloud. So that means a request from a database through RMAN that would need a backup from one of these other locations say replica or from the cloud, would automatically be retrieved through that appliance because it is aware of the locations of these other backups. And of course, the OCI storage can be made immutable through regulatory compliance settings that are available with those buckets themselves. So once you set a bucket as compliant, same policies apply for the behavior properties, meaning the backups cannot be deleted, modified, or altered, copied, moved, etc., unless you have unlocked that compliance retention. And there's a fixed time that you specify, and that time cannot be changed in either. So to finish up, we'll take a look at a few customer use cases where Recovery Appliance has really proven itself in terms of ransomware protection and transforming backup recovery infrastructure. Energy Transfer is obviously a critical infrastructure company in the US. They manage gas and other energy sources within the US, and they were struggling with backups and recoveries that were taking too long and also had potential data loss. With the Recovery Appliance used for their Oracle databases, they saw 40x faster backups, 8x faster recoveries, and a very much more efficient backup infrastructure, which they used to do with do-it-yourself using storage and other backup solutions they had to keep in sync and coordinate. One of their quotes is very insightful, that backups that were taking up to 12 hours are now completing in 15 minutes. And that is again through the incremental forever strategy. And restores that were taking up to 4 hours are completing in just about 30 minutes. Okay, so very dramatic benefits there using the Recovery Appliance. And also for the storage efficiency, because of the reduction of space, they could actually elongate the recovery window to cover more retention. We also work with a global bank that needed a very much more resilient and performant solution across their estate. They had about 10,000 databases worldwide, and they also had an exposure to regulatory and ransomware risks. So with Recovery Appliance, they see backup recovery operations completing 4 times faster. They've eliminated storage that they used to have for staging backups initially before they go to tape. And this yielded multi-million-dollar savings over the 5 years that they've been deploying these systems. And they've set up a vault site. As I mentioned before, in terms of our ransomware protection, this vault site is a one-way network for synchronization of backups and no other access to go out. This contains an up-to-date secured copy of these backups. And from there, they also offsite to a tape solution for longer-term retention. They have over 50 racks across 11 global data centers, over 8,000 Oracle databases protected, and this represents over 18 petabytes worth of backups across their estate. So huge environment here. I would encourage you to take a look at a recent IDC report that was produced for the benefits of the Recovery Appliance, and is composed of several interviews with our customers. Across the board, our customers report some great benefits: 6-month payback of the investment in Appliance, 4x faster backups, 5x faster recoveries, and 100% of the RTO and RPO requirements were met. Another US energy customer of ours saw massive efficiencies on the backup process, which they used to take 20 hours once a week over the weekend, and instead they do it in the matter of minutes now using incremental backups, and they can now do this on a daily basis. So they get a instant, if you will, full backup every day now, which is great for recovery, any kind of recovery strategy. We'll post the link actually to this report and other links at the end of the session. So let's just summarize what we've talked about today. Number one, ransomware breaches can be devastating. It is one of the top, if not the top concern in most C-level minds today. for databases is essential. It's essential because they contain the most business critical assets for a corporation. And because ransomware attacks can be very complex and sophisticated, you need a very much database aware and attuned solution to be able to combat and defend against such attacks. So my challenge is for you to go beyond traditional backup recovery. We obviously in a different world today with ransomware attacks versus traditional HADR outages, and they require modern data protection. Data security, integrity, and availability are critical for databases. My third point here in the summary is to look at and evaluate Recovery Appliance. We believe it is the world's best Oracle data protection solution on the market. It provides 3 essential technology pillars: recovery assurance, resilient architecture, and deployment in a cyber vault location. And through all of this, there's deep automated integration with the Oracle database itself as well, which provides this level of efficiency and recoverability, as mentioned. We have a website you can see on the left for more product information. We also have a number of other resources listed here, and maybe one of the panelists can paste the links here for the audience as well, so they can get to it after the session's done. We have a couple of blogs on ransomware protection and implementing immutable backups. We have a technical brief on deploying a cybersecurity hardened architecture using the air-gap cyber vault methodology. We've done a number of other sessions in the past for ransomware protection and immutable backups on our Ask Tom office hours sessions. And you can always engage with us through social media. We are on Twitter. We're also entertain questions through our office hours location, as you see here. So with that, I'll conclude the presentation.